Hello, ladies and gentlemen. Sorry that I am gone again today, but I want you to get out your packet from yesterday and do your warm up. So, pause the video, get out your packet, do your warm up. All right, so your warm up, your y-intercept is 4, so you plot the point 4, 0, 4, 1, 2, 3, 4, which is right here. And then you apply your slope, which is up 3 and over 1. Then I can go down 3 and over 1, which would be right here. And I'm going to draw my line, and because I don't have a restricted domain, I'm going to have arrows on both sides. So that is the warm-up. All right, so then if we look at the packet from yesterday, here we go. You should, whoops, that's not where I want to be yet. I'm ahead of myself. So if we look at the packet from yesterday, the first page compares these three graphs. So here in navy, you have the parent graph, okay, that y equals x line. And then in black, you have y equals 3x and y equals 1/2 x. And they all have the same y-intercept, which would have been a similarity that you could have mentioned, but their slopes are different. The black one is steeper because its slope is bigger than 1, and the purple one is less steep because the slope is less than 1. Of course, we would use more sophisticated terms other than steep and less steep. So the black line, because the slope is bigger than 1, we call that a vertical stretch, meaning we take the blue line and we are vertically stretching it. Like if I pull up, it makes this steeper when I pull up. Okay, so that's a vertical stretch. And then the opposite is true with the purple line, but instead of stretching it, I compress it. So if I vertically shrink this, it compresses. So we would call that a vertical compression. All right, we'll take notes on this a little bit later, so don't worry about trying to get it all written down right this second. So, yeah, so then the next page we looked at a positive and a negative parent graph. So the parent graph is, again, this y equals x. And then y equals negative x is the exact same graph, except it's flipped. Okay, so instead of Carl walking uphill, he's walking downhill, but the slope is the same, like it has the same steepness, it's just flipped. Of course, we would use a more sophisticated word than flipped, so we're going to call it a reflection, or that it has been reflected over the x-axis. Okay, so when we have a negative slope, we say it's been reflected over the x-axis. And then the last one, these are parallel lines, but they all have the same slope. The only difference is that they've been shifted. So like this line here is the same line, it's just been shifted up 2 because it had a y-intercept of 2. And this is the same line, except it's been shifted down 4 because it has a y-intercept of 4. Again, I'm sure you can guess we're going to use a more sophisticated word than shift. We're going to use translate. So the top one would be translated up 2, and then this bottom one would be translated down 4. So those are the three main ways that a graph can be changed. It's translated, reflected, or vertically stretched or compressed. So here are the notes on that. Here they come. Okay, so when you have y equals mx plus b, m is your slope, b is your y-intercept. Let's zoom in on this actually. So if the absolute value of m, meaning just the number, we're not worried about whether it's positive or it's negative. So if just the value of m, the absolute value of m is greater than 1, it's going to be a vertical stretch. That's when we're making that line skinnier. But if the absolute value is less than 1, then it's a vertical compression. If your slope is negative, meaning it's less than 0, it's a reflection over the x-axis. And then we look at the b's, okay? We look at the y-intercept. If it's greater than 0, it's translated up. If it's less than 0, it's translated down. So you may want to pause this video, everybody kind of jot these notes down, and then we'll look at some examples together. Okay, so examples. So this one, notice that the directions are going to say to sketch. Okay, we do not need grid paper, graph paper for this. We can just sketch these. And the first thing we're going to put on our sketch is our parent graph. So you probably want to make that dashed or dotted so that we know that it's different than this line right here. Um, and then, let's see, I know that it's going to have the same slope. It's going to have the same steepness to it because it has a slope of 1. The only thing that's different is that it's translated up 3. So that's my sketch. So here was the parent graph, and then I shifted it up 3. So to compare it, I'm going to write translate up 3. That's my comparison, and then the sketch is obviously this graph right here. So if we look at another one, I have h of x is equal to 2x. I want you to pause the video and see if you can figure this one out on your own. Okay, so the first thing you're going to do is put the parent graph in there. And then let's see, the y-intercept is going to be the same on this one because you don't have a b term, but the slope is steeper. So I'm going to make my sketch where the slope is steeper, and we call that a vertical stretch. Pause the video, try this one. All right, so to start off, just like always, I'm going to put my parent graph on my sketch. And I got a couple different things going on this time. I've got a -2 as a slope. So that means that it's going to have a steeper slope, and it's going to be reflected over the x-axis. So it is going to look like that. And then to compare it out in words, I would say that this is a vertical stretch. And it is reflected over the x-axis. So you would need to say both of those things because both of those things are true. All right, next one. Pause the video. Okay, I'm going to sketch my parent graph on there. This one, the only thing that's different is that my slope is less than 1, so it's going to have a shallower slope or a less steep slope. And we call that, when our slope is less than 1, a vertical compression. Pause the video and try this one. All right, so this one's got a couple things going on. I'm going to put my parent graph in there first. And let's see, our slope is steeper because of the 6, and it's translated up 7 because of the y-intercept of 7. So it's going to look like that, and I'm going to need to write both things out. That's a vertical stretch. And translated up 7. All right, last one, I think. Yep, last one. Pause the video. You try this one. All right, so like every other problem we've done, we're going to start with the parent graph. And this one's got quite a bit going on with it. Let's see, the slope is going to be less steep, but it also has to be negative. So I'm going to make it less steep and negative, so that looks good. And it needs to be translated down 8. So I'm going to put it about there. And then let's see, so we need to say all those things. So that's a vertical compression. It is a reflection, reflected over the x-axis, and then translated down 8. So there you go. You're now going to work on a white sheet that talks about, practices some things about function form that we talked about yesterday. And I have a worksheet with 10 problems on here that you could compare different functions to the parent function. Only thing I want to say about the worksheet that you're going to work on is starting at, like, I think number 7. Not all of the equations are written in y equals form, so you may have to change the equation to be in y equals form in order to compare these functions. If you have any questions, I'll be on Edmodo, so I'll be checking that. And your test is Wednesday, Khan Academy is due Wednesday, and we'll start reviewing on Monday. So have a good weekend, and I'll see you then.